So today we're actually going to scoop back to Unit 6, and we're going to talk about, today we're going to be connected with Unit 5 and linear lines, but in Unit 6 we had systems of equations, and eventually we're going to be solving linear systems of equations, which is actually really cool. You would have two lines, and each of the lines would have some kind of circumstance, like it's bigger than, it's less than, and then you would find out where they would both meet, and we'll be doing some shading to find the systems or where they intersect. That's what a system meant. But before we get to that cool portion, what we need to learn how to do is graph a linear inequality. So your learning target, you can identify solutions and graph linear inequalities today. And just to remind you, inequalities, what that means is greater than, less than, greater than or equal, less than or equal. Those are what inequality means. What we've been used to is y equals mx plus b, but now we're going to have an inequality, like y is bigger than mx plus b, or y is less than mx plus b. So a linear inequality is a line with multiple solutions. A linear inequality is a line with multiple solutions. So what we're used to is y equals mx plus b. That's what we learned in Unit 5. That's kind of the main connection we're going to have today. Remember that the m, or what's right in front of x, is the slope of the graph, and the b is the y-intercept. It is the same exact thing today, except we're just going to be more than the line. We're going to either be shaded above the line or below the line. So a linear inequality, notice it's the same exact thing, except instead of an equal sign, we have an inequality symbol. So we're going to be seeing things like y is greater than mx plus b. Again, remember, it's the slope is what's in front of x, and b is your y-intercept. Also, don't forget, in both cases, intercept. In both cases, y has to be alone. One of your first learning targets is to identify solutions of a linear inequality. A solution makes the inequality true. That would be something like 3 is bigger than 1. If I had that, then yes, that is a solution because it's true. Or, let's make it a line, like y is greater than x. Well, if I had the point 2, 1, I would put the 1 where the y is, the 2 where the x is, and I have y is greater than 2. No, that is not a true inequality. It's actually the other way around. So your first learning target is to identify the solutions of a linear inequality. So you're going to plug the x in and see if the y is true. And remember a point is always x comma y. Okay. So the first linear inequality we have is y is greater than x minus 3. That semicolon means that we're going to see if the next thing is a true statement with that inequality. So I want to know, is 1, 2 a solution to this inequality? That means, does it make it true? So remember, we go x, y. So my x has to go to the x, my y needs to go to the y. And then you just plug it in and see if it's true. So is 2 bigger than, what's x? 1 minus 3. Is 2 bigger than 1 minus 3 is negative 2? Yes, 2 is bigger than negative 2. So yes, the point 1, 2 is a solution, All you'd have to write is yes or no. You don't have to write it all fancy like that. Okay, so it looks like I have the same linear inequality on this next one. I have y is greater than x minus 3, colon. Is negative 3, negative 7 a solution? Does that point make the inequality true? So again, it's xy. So the negative 3 is going to go to the x. The negative 7 is going to go to the y. And you just plug it in and see if it's true. Is negative 7 bigger than negative 3 minus 3? Now remember, you plus a negative here, so they're actually the same, or just use your calculator, no big deal. Is negative 7 bigger? Negative 3 minus 3 is negative 6. This, a lot of students are going to think is true. Don't forget that the more negatives you have, the deeper in the ground you are. So this is actually a false statement. Negative 7 is smaller. It's deeper in the hole. So false, and I'll make it fancy. Negative 3, comma, negative 7 is not a solution. So that means that if we got that point, if we check that point, that the direction of the inequality, we'd have to go the other way to make it true. We don't want to include that one. Speaking of graph, let's do our second learning target. Now we're going to graph linear inequalities. So again, that just means y is greater than mx plus b. Remember, your m is your slope, your b is your y-intercept. I'm just going to say y-it. So something that you have not seen before with graphing, we're going to have solid lines or dashed lines. So this is super, super important. I don't know, you might want to highlight this, because if you have a solid line when you should have a dashed line, you're going to get it wrong. So a solid line means there's a line under the inequality. It means it can equal that line. So for example, y is less than or equal to x, or y is greater than or equal to x. What I like about this line is it's just that diagonal line that goes through the origin. So I'm just going to show you what that would look like if I had a baby coordinate plane. Then I have my slope is 1, my y-intercept is 0, so I cross it there, and then up 1 over 1, up 1 over, go the other way. And then I would have a solid line, and I might as well just show you if y is bigger than this line, we're actually going to be doing shading today. It's actually kind of cool. A dashed line means there's no line under the inequality. That would be something like y is less than x, or y is greater than x. Let me change it. Like y less than x, or y greater than x. That means it can't equal the line. It can be any other value, but it cannot equal the line. So what this graph would look like, I had a baby coordinate plane. I have the same y-intercept. My y-intercept is 0. My slope is 1. So here's my up 1 over, down 1. And then I cannot make a solid line because it could not equal these points. So what you do is make a dashed line. So it just looks like a dash saying it can't equal that, it can go up to it. And then we'll be able to do shading bigger than. So very, very, very important that you know when to have a solid line or when to have a dashed line today. If there's a line under it, you make it a full line. If there's not a line under the inequality, you make it dashed. And then this is important too. These are really little. When I made this, I was like, oh, I hope you can see it's like a heading. If it's bigger, then you shade up. That means it's all the points that are bigger than that line. If it's vertical, you would go to the right. So that would be like what I just showed. I just showed greater than. I said y is greater than x. That's what this line was. Y is greater than x. I'm going up, or equal because I have the line. This would just be y is greater than x. No line because it's dashed. If you're less than, you're going to shade down. A vertical line, you would go to the left. What I mean by a vertical line, I mean like if you had vertical as x's. So if I had x is bigger than 3, it would be like this. So let's just say that x is 3. I'm making a really rough graph. X is 3 and it doesn't have a line under it, so it would be a dash line, and bigger than would go this way. And then if I had a vertical line on the less than, a vertical line is always the x equal line. If you're unsure, you can always graph the y equals in the graphing calculator, and the y equal line is the horizontal line. You can't graph x equals in the graphing calculator because it has to be in slope intercept, but you can graph y equal line. So if it's vertical, that's x's. It would, like, let's do x's less than 1. And I would make my baby coordinate plane. And I do not have a line under it, so it would have to be a dashed line at x equals 1. And then I'm smaller. Everything smaller goes this way. Okay? Okay, so first things first. We're doing 2 of them. Graph the solutions to y is greater than x minus 2. So I wrote down the slope and the y-intercept just for you to be able to remember that you have to identify those in order to graph the line. So on this line, my slope, you have the 1 there. So it's actually 1 over 1. You're going to go up 1 over 1, up 1 over 1, up 1 over 1, etc. And then if you actually plus a negative here, your y-intercept was at -2. Just to remind you, when you graph, you have to plot the y-intercept first. You have to have a starting point. So I'm going to go ahead and graph this. I always just make the dots before I do any kind of connecting, because here you can't connect it, and maybe even write it down. So this is going, you don't have a line under your inequality, so this is going to be a dashed line. So do not make it a solid line. You do not have a solid line under it, okay, because it's only greater than. And if it's only greater than, what you need to do, it's only greater than, what you need to do is make it a dash line. You can't say that it actually equals it. Okay, so make my dot at the y-intercept, so -2 right here. And my slope is 1. So up 1 over 1. You always go to the right, up 1 to the right 1. And I'm going to go back, or go to the left here. Down 1, left 1, down left, and I can see my pattern. And then I got to make it a dashed line. And what I'd like you to do is really make sure you extend it. So here, I'm going to make it a different color so you can see. And maybe you want to highlight your lines. So this should be a dashed line that follows that same pattern. Make your arrows. And I am bigger than it. So bigger than it, I would go up. So I'm greater than, so I should be going up on the line. I should color up. So, and I just kind of shade with just a few lines. It's all of these. It's not, and you can't equal that line because it's dashed. Now the connection with the first learning target, where we check solutions, what I always do is check to make sure I have a point right. So what's our line? Y is bigger than x minus 2. Okay, so I always choose the origin. So I'm going to check, is 0, 0 a solution? Should that be colored in? So I'm going to go ahead and plug in. Is 0 bigger than 0 minus 2? 0 is bigger than -2. That's true. So you should have that point included, which we do in our shaded line. So I did go the right way. So if you ever wonder if you did not go the right way, or if you should go up or down, just pick a point. 0, 0 is always the easiest point to pick to see if it's true. If it's true, you color that side in. If it's false, you color the other side.